Reinforcement. Let us see some of the major headings in reinforcement. They are general, basic terminology, handling of steel, testing of steel, bar bending schedule, tools and equipments, and steel in different member. Now let us look into general. The most commonly used types of steel bars are TMT bars, which are thermomechanically treated bars and are manufactured by a special process of quenching and tempering which imparts uniform strength, more ductile and weldable without adding carbon, which will have ribs over it at equal intervals. CTD bars, which is the abbreviation of cold twisted deformed bars, which have continuous spiral twisting throughout the length of the bar. Next, we see about basic terminology. Anchorage length. This is the additional length of steel of one structure required to be inserted in other at the junction. For example, main bars of beam in column at beam column junction. Development length. Development length can be defined as the length of the reinforcement bar embedded in concrete in order to develop full bond stress. These bond stresses prevent the reinforcement rod from getting pulled out of the concrete member because of tensile stresses when loaded. Longitudinal reinforcement. The main reinforcement provided in an RCC member to take care of the bending moment is called as the longitudinal reinforcement. Proof stress. It is the minimum stress over a given area that can create a permanent deformation on it. Reinforcement curtailment. The steel reinforcement can be cut or stopped as it is no longer required to resist the flexure. It also makes the RCC member more economical. Stress. It is the measure of force acting over a unit area. Tensile strength. It is the maximum amount of tensile stress that a member can be subjected to before failure. Transverse reinforcement. The secondary reinforcement in an RCC member to provide lateral support to the longitudinal reinforcement against buckling is called as transverse reinforcement. Yield point. It is the point at which the elongation of a bar under tension increases without increase in the load acting on it. Yield stress. It is the lowest stress in tension at which yield point is reached. Let us go into the topic handling of steel. Steel stockyard. This is a specially allocated secure area where the reinforcement steel is confined and stocked. Steel workyard. This is a specially allocated area where reinforcement cutting and bending works takes place. Well, we go into tools and equipments. Twisters and tongs are used for straightening or bending the steel bars. Plumb bob are used to check verticality. Measurement tape are used to measure any distances. Bolt cutter and the electric bar cutting machine are used to cut the steel reinforcement bars. Bar bending table and the electric bar bending machine are used for bar bending. Hammer are used for driving and braking purposes. Chisel are used for manually cutting the rods. The chalk is used for marking the rods at intervals where they have to be cut. The binding hook is used to tie the binding wires and fabricate the reinforcement steel as per design. Testing of steel. The steel that arrives at the site should be visibly checked for any discrepancies. Deformed, severely corroded, cracked and split bars should be rejected. Samples should be taken for lab tests such as rolling margin test, tensile strength test using universally testing machine. Then bending test. Next rebending test. Chemical composition of steel. The maximum allowable content for carbon is 0.3 in both Fe415 and Fe500 grade of steel. The maximum allowable content of sulfur is 0.06 for Fe415 and 0.055 in Fe500 grade of steel respectively. The maximum allowable content of phosphorus is 0.06 in Fe415 grade of steel and 0.055 in Fe500 grade of steel respectively. The standard code for steel is IS 1786-2008. For grade Fe415 steel bar, the yield strength of the steel bar should not be less than 415 Newton per mm square, and its ultimate tensile strength must be a minimum of 485 Newton per mm square. The percentage of elongation should be less than 14.5% respectively. For grade Fe500 steel bar, the yield strength of the steel bar should not be less than 500 Newton per mm square, and its ultimate strength must be a minimum of 545 Newton per mm square. The percentage of elongation should be less than 12% respectively. Bar bending schedule. Bar bending schedule is a data sheet that gives all the necessary details about the reinforcement to be provided in the particular RCC job. It is also very useful while steel reconciliation. The sample is shown here. Let's proceed into steel in different member. Bottom mat. This image shows the typical picture of a footing bottom mat. All works should be executed as per good for construction drawing. Chairs. These are steel elements which separate the different layers of reinforcements for members like footings and keep them in their respective positions while concreting. Footing top mat. This image shows the typical picture of a footing top mat and additional rods. All works should be executed as per good for construction drawing. Column in footing. Column reinforcement should be placed as per column marking. Column orientation should be checked properly before concreting. Column verticality should be checked by plumb bob. Prop support to be given to maintain column verticality before concreting a footing. Column reinforcement. Longitudinal bars, transverse bars is nothing but stirrups. Column lapping are the sequence of work in column reinforcement. The column bars need to be supported from all four sides using props and the verticality of the column to be checked. Stirrup spacing, hooks and links, number of rods, dia of rods should be as per good for construction drawing. Stirrups. The shear reinforcement for beams and columns are called as stirrups. This image shows the stirrups in a column. Staggering. Staggering is very important in column reinforcement. Vertical bars of column shall be lapped in regular zone only, and if should be staggered, that is, not more than 50% of bar can be lapped at one section. In addition to that, minimum clear vertical distance between lapped bar shall be 0.25 times lap length. Beam reinforcement. This image shows the bottom rods in a beam member. This image shows the top rods in a beam member. This image shows the stirrups in a beam member. Top reinforcement, bottom reinforcement, additional rods, stirrups are the elements of beam. All the beam reinforcement should be executed as per good for construction drawing. This image shows the additional reinforcement in the plumbing cutouts in slab. Chairs. These are steel elements which separate the different layers of reinforcements for members like slabs and keep them in the respective positions while concreting. Spacer bars or pins. These are steel elements which separate the reinforcement and hold them in position. Cover block. This image shows the cover block placed in the slab. Cover block should be made of cement mortar 1:2 and it must be used after 7 days of curing. It is mainly used to ensure that the reinforcement is completely embedded in concrete. Torsional reinforcement. As per Annexure D of IS 456, corner of slab are prevented from lifting the slab. The torsion reinforcement shall be provided at any corner where the slab is simply supported on both the edge at the corners. The torsion reinforcement need to be provided only in framed construction where slab are restrained by beam. This image shows the template fixed in toilet sunken portion.
Action.
In main beam and secondary beam junctions, the top rod of the secondary beam should be bent in L shape horizontally, not vertically, to transfer the load horizontally to the main beam member. Development length of tension and compression bars in limit state method. The type of bars used are the deformed bars. The development length for grade of steel of Fe415 for tension bars are M20 grade of concrete where 47 times of its dia, for M25 it's 41 times of its dia, for M30 it's 38 times of its dia, whereas while coming to the compression bars, it's for M20 it's 38 times of dia, for M25 it's 33 times of its dia, for M30 it's 31 times of its dia, for M35 it's 27 times of dia, for M40 it's 24 times of dia. Now coming to Fe500 grade of steel, the development length for tension bars for M20 grade of concrete are 57 times of its dia, for M25 it's 49 times of dia, for M30 it's 46 times of dia. While coming to the compression bars, for M20 grade of concrete it's 46 times of dia, for M25 it's 39 times of dia, for M30 it's 37 times of its dia, for M35 it's 32 times of its dia, for M35 it's 32 times of its dia, for M40 it's 29 times of its dia. For footings, the cover must be of 50 mm which is distributed 4 in numbers per square meter. For footing in waterlogged area, the cover must be of 75 mm which is distributed 4 in numbers per square meter. For columns and pedestals, the cover must be of 40 mm which is distributed 1 number per side for every half meter length in both horizontal and vertical directions. For beams, the cover must be of 25 mm which is distributed 1 number per side for every half meter length in both horizontal and vertical directions. For slabs, the cover must be of 20 mm which is distributed 4 in numbers per square meter. Thank you.